Okay, so now we're on number, what number are we on now? Number 9. Okay. So it says, AB is shown on the graph to the right. Answer the following questions. So first it wants to know what the slope of AB is. So if you want to, you can count all the way down and all the way over. I can see that it has a point right here, so I'm just going to kind of count down and over from here to here. So we're going down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7. Okay? So since moving from left to right, we're going down. This is a negative slope. So this is going to be negative 4 sevenths for the slope. Okay. Start back on. Okay. So it says, what is the midpoint of AB? All right. If you want to get the midpoint, you can use midpoint formula, which says that you add your x values, so negative 7 plus 7, and divide by 2, and you add your y values and divide by 2. Negative 7 plus 7 is just going to be 0, and 8 plus 0 is 8 divided by 2 would give you 4. So this is our midpoint right here. A lot of the time when it's on a graph, you can kind of eyeball where the midpoint is, but just make sure you double check, like if there's a couple of points nearby that are close to that one, then you want to double check that it is exactly in the middle. Okay. All right. What are the two things you do to slope to determine its perpendicular? So perpendicular slope is the opposite reciprocal, which means you change the sign and flip the fraction. Okay. So where it says, what is the perpendicular slope of AB? We got that the slope was negative 4 sevenths. We need to change the sign, which means make it positive, and flip the fraction. So it becomes positive 7 over 4. Okay, now it wants the equation for the perpendicular bisector of AB. Okay, half of this problem is knowing that the slope should be 7/4. Okay? We write equations in the form y equals mx plus b, where m represents your slope and b represents your y-intercept. So we know that the first part of the equation is going to be y equals 7/4 x. We also need to know what the y-intercept is going to be. So a perpendicular bisector is two things. It's perpendicular and it's a bisector, meaning it goes through the midpoint. That's why this part of the question asks you to find the midpoint. Because if you know that it goes through this point, or if you know that this is the midpoint, then you know that the perpendicular bisector is going to go through that point because it's a bisector. So really, this makes this problem kind of easy because when you're trying to get the y-intercept, we can already see that it's going to cross the y-axis at 4 because it's going to go through this midpoint. So your plus b is just plus 4. Okay. So we have y is equal to 7/4 x plus 4. Okay. And just to show you what that looks like, so if we have a point here, the slope is 7 over 4, so that means we go up 7, 1, 2, 3, 4, 5, 6, 7, and over 4. Okay. So that would be another point on that line. And then we could go backwards, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Okay. And you can see that this line makes a right angle with this one, okay? And it's going through the midpoint. So that's how we know it's perpendicular bisector. Okay. Next, it says write the postulate that proves or disproves the triangle congruency. And we've got any of these or not possible. So here, we have a right angle. That's a clue that it might be hypotenuse leg. But you have to make sure that it counts the hypotenuse as congruent and the legs, which in this case, it does. So that makes this hypotenuse leg. Okay, in this diagram, we have two pairs of congruent angles, another two, and then they share a side. The side is in between those two angles, and that's why this is angle, side, angle, and not angle, angle, side. Okay. The difference, okay, let me find the angle. Okay, so here we're going to take a look at this one because this is the angle, angle, side. So here we have a pair of sides, and we have a pair of angles, and then we have vertical angles. Okay. The difference between these, here, if you start at this angle, it goes angle, side, angle. The side is in between the two angles. It's connected on both ends. Here, this side only connects to one of the angles, and that's because it's not in between. It goes angle, angle, side, because it's not in between those two angles. Okay. All right. For this one, we have a pair of vertical angles, but that's angle, 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 which is NP. This does not prove congruence. Okay. Here we have two sides and then a pair of vertical angles. That's side, side, angle. So that's NP, because that doesn't prove congruence. Okay. Here we have a right angle, which I would say to be on the lookout for HL, if that's the case. But when we look at our hypotenuse, it's not shown to be congruent. So we're not going to use HL because we have to have a hypotenuse congruent if that's the case. But what we do have is side, angle, side, because we have two pairs of congruent sides and an angle in between. All right, last one. We've got one pair of congruent sides, another, and they share the middle. So that's side, side, side. Okay. Number 11 and 12 are asking you to find the midpoint. So you're going to use midpoint formula here, which just says that you add your x values, so 4 and negative 6, and divide by 2, and add your y values, and divide by 2. You have to do this separately because your calculator cannot do a comma and then separate parentheses. So 4 plus negative 6 divided by 2 gives us negative 1. And then separately, 10 plus 8 divided by 2 gives us 9. Okay. So there's the midpoint. All right, for this one, so we have 12 plus negative 8 divided by 2 are 2 x's, and 4 plus 16 divided by 2 are 2 y's. Okay. So we've got 12 plus negative 8 divided by 2 gives us 2, and 4 plus 16 divided by 2 gives us 10. Okay. Okay, scooting down. It says, for each transformation described, name the parts that are congruent. So this is a translation to the right and down. So there was no rotating, there was no flipping, there was no changing sides, which means that if we want to find the congruent parts, we just need to look at, if this were to scoot from here to here, what matches. So AB is going to match side MG, because it's the same orientation, it's just slid over here. And then C is going to match angle R. Okay. So if it's a translation that is letting you know that it's not flipping, it's not rotating, it's just a slide. It's scooted over here. Okay, so that's how you match up those parts. Now, if it says a reflection, that means that this flipped over this line. Okay, so it's kind of like a mirror image. So that means that angle C and angle P would go together. Angle B and angle R would go together, and then angle A and angle T would go together. So we're going to use that to help us figure out these congruent parts. So the first one, it says CBA would match which angle? So B matches R. So we're going to write that CBA matches angle PRT. CBA, PRT. Okay. TP would match CA. And then last, RPT would match triangle. So it goes RPT, so that's going to match BCA. Okay, number 14 and 15. And then you can also omit 16 because it doesn't have the correct answer. All right, so 14, how would you find the distance between D at 1/8 and M at -7, -3? So on your green chart, you have the distance formula. It's x2 minus x1 squared plus y2 minus y1 squared, and take the square root. Okay. So you don't really have to worry too much about x2 and x1. All that's really important is that your x's need to be in the parentheses together and subtracted, and your y's need to be in the parentheses together and subtracted. So we have our x's are 1 and -7. So I immediately see a problem with A and B because 7 is positive, not negative. So I should take those out. So now it's either between -7 minus 1 squared minus this, or -7 minus 1 squared plus this. So look at your formula. Okay. It's supposed to be a plus in between these two. So this is a minus, this is a plus. It's got to be answer choice D. All right, for the next one, we've got -5 and 10. Okay, so again, same issue here. These 5s are positive, so we need to take those out. Okay. And same difference. This is a plus, this is a minus. So in between should be a plus, following the formula. All right, last page. Okay. So we're given that these two triangles are congruent. We want to plot these 3 points first. So point A is going to be at 2, 6. So there's A. B is at 7, 6. Okay. And C is at 7, 0. So there's C. Okay. Then for the other triangle, it says that x is at -2, -1, and z is at -2, -7. Okay? And we're going to place point y so that it makes a congruent triangle to the one that we had before. Okay, so the important thing here is that these two sides should be the same, and in between you should have that same right angle so that it's like a side angle side, and we know that they're congruent. So this has a length of 6, and this has a length of 5. 2, 3, 4, 5. Okay. When we count this side over here, 1, 2, 3, 4, 5, 6. So that means that we need to place point y so that it's 5 away. So we could start from here and count 1, 2, 3, 4, 5. Okay. So this is one option for where y could be, is at 3, -1. And the triangle would look like that. Now, that's not the only direction that you could go, because you could go 5 this way or you could go 5 that way. So we could go back 1, 2, 3, 4, 5. Still a congruent triangle because it's still got measurements of 5 and 6 and a right angle. Okay. So another y could be at -7, -1. And it could look like that. You're not going to be asked to give this many answers for y, but I don't know which direction that they're going to go. So you want to be able to plot these different points, and then as long as these sides are the same, then you know that those triangles are the same. There's 2 more y's that you could technically have, although it's going to look a little funky. So instead of going 5 this way and 5 this way, we could go 5 down here. So 1, 2, 3, 4, 5. So y could be, let's see, that's at 3, -7. Okay. And so the triangle would look like this here. Or we could go 5 this way. 1, 2, 3, 4, 5. And that would be at -7, -7. Okay. So those are all the possible y's that you could have that would make a triangle congruent to that one. So the most important thing is that if this has sides of 5 and 6, then this triangle should have sides of 5 and 6. And as long as it does, you're good. Okay. Which of these angle pairs are congruent? Circle all possible answers. So there's 2 pictures. Okay, one where we've got angles 1 through 8, and another where we've got 9 through 16. The difference between these 2 pictures is that here lines are parallel, here they're not. That makes a difference because we have the rule, okay, so we have congruent angles and we have supplementary angles. The congruent angles are alternate interior, alternate exterior, and corresponding. And the supplementary are same side interior and same side exterior. But these rules only apply if the lines are parallel. So that means that these rules will work for these, but it's not going to work through 9 through 16. Okay? So when we're circling them, okay, 1 and 5, these are corresponding. Those lines are parallel, so those will be congruent. Let me pause this. Okay, unpausing the video. Okay, so we've got 1 and 5 are corresponding. They're on the parallel set, so they're good. 4 and 6, those are same side interior, so those are supplementary, so we don't need to worry about them. We've got 2 and 7. These are alternate exterior. Here's our transversal. Different sides of the transversal outside of the 2 lines. Okay. So those are congruent. 9 and 16. These are alternate exterior, but the lines are not parallel. So because they're not parallel, that's the only reason why we're not including that. Otherwise, they would be included. All right, 10 and 15. These are another pair of alternate exterior, but they're not on parallel lines, so we can't include them. 13 and 16. These are not on the parallel set, but they're vertical angles, so they're different. Vertical angles are always congruent no matter what your lines are like. Okay. And it makes sense because when you think about these 2 angles, this line isn't even affecting those. It's totally not even touching them. So this would not affect whether these are congruent or not. Okay. All right, and last 11 and 12, those are a linear pair. Linear pairs are supplementary, not congruent. Okay. It says, which of these angle pairs are supplementary? So this time we're looking for same side interior, same side exterior, or linear pairs. Okay. Universal. Okay, so I'm writing that they're all universal to mean that whether lines are parallel or not, linear pairs are always supplementary, no matter what. Okay, so 1 and 5, these are corresponding. Those are congruent, not supplementary. 4 and 6, these are same side interior. Those are supplementary, and it's on parallel lines. Okay. All right, we've got 2 and 7. Those are alternate exterior. Those are congruent, not supplementary. 11 and 13, these are same side interior, but the lines are not parallel, so we're not going to include them. 10 and 16, same problem. These are same side exterior, but the lines are not parallel. 13 and 14, these are a linear pair, so we can include them. These, even though they're not on the parallel lines, okay, linear pairs are always supplementary, no matter what kind of lines you have. And then 9 and 12, those are vertical, which are congruent, not supplementary. Okay, so knowing all of that, if we're given that angle 3 is 70, we can find these other angles. So I like to do this little trick where I circle the first set of angles that are congruent. So like I know that 1 and 4 are congruent, 5 and 8 are congruent. I also know that 1 and 5 are congruent, and 4 and 8 are congruent. So all of these angles that I circled are the same. Then what I do for the other pair, the ones that you didn't circle, I put a box on them. Okay? So what this represents, when you're looking at this picture, any of them that are the same, like they have a box, those are congruent. Any of them that are different, those are supplementary. Hey.
How are you?
Good. Okay. So the ones that are circled are the same. The ones that are different are supplementary. Now the ones over here don't apply unless it's a vertical or a linear pair. All right, so if angle 3 is 70, 3 and 2 are both boxes. They're vertical angles. They're going to be congruent. Okay. 3 and 5, that's a box and a circle, which means that they will be supplementary. So 180 minus 70 gives us that 5 would be 110. Okay. All right, 3 and 7. These are both a box, which means that they'll be congruent. So 7 is also going to be 70. Okay. Next it wants to know if angle 6 is 60, what are the rest? So 6 and 7, those angles are both boxed, which means that they're congruent. 6 and 2, both boxed, so they're congruent. 6 and 4, those are same side interior. They're different, so they're supplementary. So 180 minus 60 gives us that 4 would be 120. All right, suppose the measure of angle 9 is 95 degrees. What are the others? So it first wants us to compare 9 and 10. These are a linear pair. Okay. Linear pairs are supplementary, so we can subtract from 180. So that gives us 85. Okay. 9 and 11 are also a linear pair, so that would also be 85. 9 and 12 are vertical, which means that they should be congruent. All right. This one is just testing you to make sure that you know if lines aren't parallel, it's not going to be the rules. So it says, knowing that the measure of angle 9 is 95, would you be able to find the measures of angle 13, 14, 15, and 16? No, because they're not parallel. Number 19. So it says the figure to the right is a prism, and we're trying to determine what's true and false. So first, it says AC is parallel to DF. When you're looking for parallel lines, as long as the lines are going the same direction, they're parallel. Because any time that you have lines that are going the same direction, there's always a flat surface that could connect them. If I have two lines like this, I could connect them with a rectangle, even if they're going like this or however, okay? So this would be true. They are parallel. Next, AB is perpendicular to AD, so it's looking at this line and this line. Now I know that there's not a right angle in the diagram, but based on the fact that this is a prism, we know that these two sides are going to be parallel, so that means that right here, these are forming a right angle. Okay. So that's true. All right, AC and BC are coplanar. So we have this plane, this flat surface that's up here. AC and BC are on that same plane, so yes, they're coplanar. That's what that means. Next it says DE and CF are skew. Skew lines are lines that are going different directions, okay, but will never intersect because they're on different planes. For example, if I had a pin on my paper and I had another pin up here, they're going different directions, but they're not going to intersect because this pin is up here and this pin is down here. These lines are going different directions, but they're not going to touch each other because D is back here and C is up front. So yes, these are skew. Next, AB and DE are coplanar. Coplanar means on the same plane. These are both on this plane back here. So that's true. Okay. EF and BC are skew. Here's EF. Here's BC. These are going the same direction, which means that they're parallel, not skew. This is false. DF and BC are perpendicular. Well, DF and BC aren't even touching each other, so they can't possibly be perpendicular. And last, AB and DE are skew. They're on the same plane, and they're going the same direction. So these are parallel, not skew. That's false. Okay, so let me scoot this down so you can see better. Last problem, okay, and you will have a problem that's on the test that's almost exactly like this, okay. So, really, the ultimate goal, it's broken into several parts, but these are the several steps that you're going to have to do in order to get to this one, which is to write an equation that's parallel to AB and goes through the point 2, 1. Okay, so when you're doing this kind of problem, you need to start with getting the slope of your original. So counting the slope, okay, I can kind of see that this is the middle point, so we can go down 4 over 1. So slope is rise over run, so we're going down 4 over 1. Our slope is -4. Okay? Parallel lines have the same slope. So the slope for a line parallel to AB, also going to be -4. I'm going to skip these for now because these aren't related to this last question. Okay. Now the last one, we have our slope, we need to make the equation go through this point to 1. So here's how you get that equation. We write equations in the form y equals mx plus b, where m represents your slope and b represents the y-intercept. We already know our slope. It's going to be -4. So we've got this part of the equation so far. We need to figure out what's our plus b. Okay. So the way that you do this is by taking your 2 and 1, your x and y, and plugging it in here. So we have that our y is 1, our m is -4, and our x is 2. So we have all of this plugged in, and now the only thing we have to solve for is the plus b. So we're going to do -4 times 2. That gives us -8 plus b. And then since this is a negative and we're adding it, in order to get rid of that -8, we need to add 8. So we have 9 is equal to b. Okay, so then our final equation will be y is equal to -4x plus 9. Okay.
Why is the parallel slope to AB still -4?
Because parallel lines have the same slope. Now, perpendicular, which is what I'm going to do right now, that's the one that's opposite reciprocal. Okay? So here, this one, it wants the perpendicular slope to AB. That's where you're going to change the sign and flip the fraction. So that should be 1/4.
So it wouldn't be like +4, it would be 1.
Positive 1/4, right. Okay. So then it says, what is the equation for the perpendicular bisector? Hold on, it's good. Kind of loud. Okay. So last question is wanting us to get the equation for the perpendicular bisector. So we already know that our slope is going to be 1/4. Also, because it's a bisector, that means that it goes through the midpoint. So here's the midpoint of that line. So what you can do, we already know that it's going to start out as 1/4 x. We need to figure out what the plus b is. So you can actually just count. So if our slope is 1/4, that means that we go up 1 over 4. So there's another point on that line. Going backwards, you would go down 1 and back 4. Okay. So then connecting that, here's our perpendicular bisector. And now that we've plotted those other points, you can see that it crosses the y-axis at 4. So that's going to make the equation 1/4 x plus 4. Okay, good luck on your test tomorrow. I wish you the best.